Welcome to this machine learning course. Machine learning is part of a bigger topic, which is artificial intelligence. And before go to the details of machine learning, it's better to know a little bit about artificial intelligence itself. Artificial intelligence is the creation of computer systems that can perform tasks typically requiring human intelligence. And it can break down into two categories: artificial general intelligence and then narrow AI. So let's see what are these two categories: the artificial general intelligence or AGI and the narrow AI. The AGI is a type of artificial intelligence can understand, learn, and apply knowledge across a wide range of tasks. Basically, the AGI is a system that can act like human intelligence. The Although AGI or any artificial intelligence system does not have consciousness or does not have feelings, but through the calculations and AI models, they can mimic whatever human intelligence can do. Right now, we are not at the point that we can claim we have AGI. We haven't reached that, but we are getting close with the introduction of uh, LLMs, large language models, like ChatGPT. We are getting closer and closer, but at the moment, we are not there yet. And by mimicking human intelligence, we mean like these examples or much more. Human intelligence can do much more: observation, learning, understanding, reasoning, math, generalization, connecting the dots. And to get a better idea of human intelligence, let me tell you a made up caveman story. So if we go back to the Stone Age, and the caveman was probably finding a cave to shelter there. And when he was hungry, he was going out and, uh, for example, finding berries to eat. And that's how he was surviving, right? And the the number of problems that the caveman had at that point was very limited, and they were very primitive. So for example, in the morning he get up and he feels hungry. So the problem that he's facing at that moment is hunger, how to deal with this hunger. And he go out and find berries and eat. This is similar to an animal level of intelligence that many animals eat berries too or find other fruits. And then when he's done with his sense of hunger, then he feel tired. Then he wanna rest, right? And then he go back to his cave and rest. and this cycle continues. So for example, like very simplified caveman here, but he has two problems. He get hungry and he get tired, and he has two simple solutions for them. Go eat berries and then go back to the cave and rest. And many animals are able, their intelligence are able to um, make them able to do exactly the same things, like find a shelter and go look for food uh, and deal with the problem of hunger. But then the difference between a human intelligence and an animal intelligence is that after thousands of years, after millions of years, the animals are still doing the same thing, but human changed a lot, right? And we are here because of the way that human intelligence works. So let's go back to the caveman story again. And I like we are in the Stone Age, and I wanna focus on this some of these abilities that human had. So one is observation, right? So the caveman was doing his uh, his routine, eating and resting, and then one day the caveman saw that there's a bear. The bear is hunting, and the bear with his claws or with his teeth, he attacked a deer and then uh, eat the deer. So bears also can eat berries, but also they can hunt and eat meat. Then the caveman think that okay, so the bear hunt the deer. How did the bear hunt the bear? How did the bear hunt the deer? Then he noticed, he observed the sharp claws. Then he remembered that when he was handling the rocks, some of the rocks are having sharp edges, right? So he again observed that the some of the rocks that I touched were sharp, right? And then he's connecting the dots. So bear claws are sharp, and then it helped the bear to hunt. Some rocks edge are sharp, so maybe the rock can help me to hunt too. Then he noticed that then he grabbed the a rock with the sharp edge and then go for hunting, and it didn't work. It didn't cut through. And then he again put his observation together, and then he think why this didn't work. And then he again compares with the claws of the bear. Maybe there is a dead bear he found somewhere, and then he could examine the claws, and then he said, okay, this is sharper and longer and narrower, and the rock that he found is not like that. So then he remembered another observation of him, that some rocks are harder than the other rocks, and then when they smash together, the the softer rock can break down and create sharper edges. Then he connect the dots like this, that okay, for me to hunt the deer, I need to have sharper objects, and the only sharp object I know right now is the rocks. I don't have claws, and the one that I can find, they are not sharp enough. So I need to build sharper rocks so I can hunt with that. And then he trial and error, and then eventually he succeeds, right? But look at what happened here. The caveman was the caveman was he could survive with the berries, like other animals. Many animals survive with the berries, and they don't bother with this kind of uh, uh, thinking or observation. They just they can they can survive, so they survive. But the human intelligence is not like that. So he could survive, but then he observed, he find a new way of surviving. So he had two problems yesterday: hunger and resting. The hunger problem was becoming another problem, which was finding berries, and he knew how to solve that. But now today, he added a new problem to his problems voluntarily, because he want to try that. No, he has more problem and he needs more solution. So, so one of important human intelligence capabilities is defining a new problem that didn't exist yesterday. Now the caveman defined a new problem. I wanna eat meat and I wanna hunt. Now I need to find a solution for that. And that's how caveman, day after day, added to his problems and then added solutions. With every solution, with every problem, there was a door to newer problems and more advanced problems. And then it requires more advanced solutions. And then day by day, um, it changed the way human live. While when the animals didn't do that, didn't have that capability in their intelligence, they are living pretty much the same as the caveman was living thousands of years ago. So that's the kind of intelligence that the AGI need to have to be called AGI. It need to be able to observe, it need to be able to define new problems and solve those new problems and evolve and get more advanced and get more advanced. So so now you know that why just talking to ChatGPT is not enough, but it's a big step. We are going to be very close, but we are not there yet, because these are the capabilities that AGI need to have. The AGI is the caveman, the LLMs, um, the ChatGPT is the caveman, and we need an AGI that is able to to transform this caveman to a more advanced caveman, and we don't have that AGI right now, but we are close. So I mentioned in general what should be an AGI be able to do to be considered AGI, but there are some AGI tests that the AGI need to be able to pass first uh, to be able to be AGI, and one of them are uh, is Turing test, which uh, an observer will talk with a AI system and a human while he don't know which one is which, and then if he cannot distinguish which one is human intelligence and which one is the the AI, then that AI is passing the Turing test. Having said that, the ChatGPT type of uh, language models are already passing the Turing test, but it doesn't mean that we are AGI. It just means that we are getting very close. The AGI need to, as I describe here, need to do much more than just passing the Turing test. But we are getting very close. Like in a near future, we're gonna have AGI, and then we're gonna get to the point that is called singularity, and that's the point that the artificial intelligence systems surpass human intelligence in terms of defining new problems and solving them and evolving. And that's a unknown point. What's gonna happen after that is really unknown, and, and many people are nervous about that, and we can't blame them because what if they define that the humans are the problem and they want to solve that, right? If they surpass the human intelligence and then they are defining the problems and solving them, what if they define human race as the problem and try to solve that? That's scary, right? And that's the subject of many sci-fi movies, but we are getting to the point that it's not sci-fi anymore, and we are getting uh, to the point that to have a real taste of this uh, artificial intelligence, the AGI. So this part was the AGI, the first part of the AI that we haven't get there, but we are getting close. And that's an AI system that can act like human intelligence, and it have a broader scope for solving problems. And then the other side of the AI, the other area of AI is narrow AI, and that's mostly the one that we are dealing with on daily basis. And narrow AI, or also known as weak AI, is the artificial intelligence doing very specific tasks. And specific tasks like predicting the temperature tomorrow, or predicting the stock market, or the price of houses. Very, very specific, special tasks that they can do, and they can do it much, much, much uh, better than human. So um, that's uh, that's already surpassing human intelligence, but because it's so specific, there is no warism here. Like there is no way narrow AI or a weak AI that can predict very well uh, the housing prices causes a problem, like itself cause a problem for humanity. The people that using it may cause problem, like the ones that predict something very well, they can abuse it, but the AI itself cannot cause any risk. And the narrow AI also have many subcategories under, and I have listed a few here, like natural language processing or NLP, which is mostly for understanding the human language, uh, like understanding it, summarizing, and also generating. And this is also again is very related to the LLMs, large language models revolution, and like the ChatGPT type of systems. And and there are other areas, rule-based systems, that the rules are defined by the experts. Um, the expert systems, they are systems that mimic decision-making abilities. Computer visions, detecting things in the images and other things. Robotics, robotics is a collection of different technologies like mechanical engineering, electrical engineering, computer science, artificial intelligence. It's not purely artificial intelligence, but artificial intelligence is a big part of it. So, um, so these are not the focus of our course. Our course is mainly focused on the machine learning, which is a subset of AI that focuses on development of algorithms and statistical models that enable computers to learn from and make predictions or decisions based on data. So we have in machine learning, in nutshell, we have data that we collected, and we wanna build uh, uh, statistical models or algorithms that look at that data and help us predict or make decisions. And they are purely mathematical uh, models and work with with numbers. So that's the thing that we're gonna focus, and we're gonna go uh, dive deep in this area. But before we move on from this part, it's worth noting that ML is not like completely separate from all these other areas under narrow AI or AGI. As I mentioned, the LLMs are making a big uh, advancement in the NLP, and LLMs are part of the machine learning. They are neural networks, and they are part of the machine learning that we're gonna get to them. But it's not that NLP has other ways of like solving problems, but also machine learning is used widely uh, in NLP and in other like computer vision. Machine learning is definitely a tool that is used in robotics. Definitely, machine learning is used. So these are not fields that are completely separate. They have a lot of overlap, but to just know that uh, to have a big picture here, we we have listed them here, and they have different purposes. But our focus uh, is on the machine learning, and the use cases can be in other area of AI uh, as well.